Welcome to qnawire.
Okay, so before we talk about the direction of the current, we need to understand that when we'll have some non-zero current. So as you can see, you have an uniform magnetic field and then you have a circular loop. Now we need to understand that if the magnetic field is changing, only then we'll have some non-zero current. So if you look at the problem, we have three different sections where you have B is increasing, B is decreasing, and B is constant. So we can easily say that if B is constant, there's no induced current. So our induced current will be zero there. But then let's talk about the first part where your magnetic field is increasing. So as you can see, your magnetic field is pointing towards the page, and so let's figure out how to find out the direction. So remember that we have some increasing current and remember we have some increasing magnetic field. So now we have to look at Lenz's law, which tells us that if there is some change in current, the circular loop will try to oppose the effect. So basically your magnetic field is increasing towards the page, so there will be some opposing magnetic field, which will be outside, which will be pointing towards us, right? So let's actually mark those. So let's say these will be the magnetic fields that are pointing towards us, right? So now we know that these are the magnetic fields that's been induced because because our B is increasing. So if we know that, okay, our magnetic field is pointing towards us, we can use our right hand rule. And if you look at chapter 28 and section 5, it says that you point your thumb towards the direction of the magnetic field, and then you curl your fingers, and that will give you the direction of the current. So if we point our thumb towards us, because as you can see the magnetic field is towards us, um, and you curl your fingers, and you will see that the direction is anti-clockwise. And so that's how you figure out if the B is increased, if the magnetic field is increasing. Similarly, let's talk about what happens if B is decreasing. So let me rub this part. Okay. Yeah. So if B is decreasing, so the loop will again try to induce some magnetic field towards the page because it wants to oppose the effect. So there will be some induced magnetic field towards the page now, like that. So if you have some magnetic fields that are induced towards the page, you do the same thing, you apply your right hand rule. So you point your thumb towards the page, and then you curl your finger. So if you do that, you will see that the magnetic field is pointing this way, which is clockwise. So to summarize, we have to know when to apply our Lenz's law. So if there is change in magnetic field, it will try to oppose it, and that's what Lenz's law tells you. So part A will be anti-clockwise. uh, Part B gives you clockwise direction, and for part C, oops, will have zero current. Okay, thank you.